Before beginning empirical and molecular formulas, just to give you just a rough idea of where these things come from. So I'm just choosing two instruments. There's a lot more than just two, but one of them just takes the compound and just burns it and then is able to detect these particular elements, and so it can give you a percentage of those elements in the substance, and so that'll give you the empirical formula if it's made up of this stuff. The mass spectrophotometer you're quite aware of also already, so you can see it's very easy for it to get a molecular mass because the highest peak is just the molecule that has a charge. If you do a further, more difficult in-depth analysis of the isotopic ratios, you can actually get to an empirical formula that way as well. And the fragments also help. Okay, so that's how we get some of the ways we get the data for an unknown compound. So first of all, what are these two, just in case we have jumped too far on that? So the empirical formula is the lowest whole number ratio, and the molecular formula is the actual molecule. Okay, so they can be the same. So that's the empirical formula, and if this was the actual compound, then it's the molecular formula as well. This one can't be an empirical formula because it is a molecule that looks like this, and the lowest whole number ratio would be CH2, so you can still divide it by 2. Same with this one, has to be a molecular formula, can't be empirical formula. H2O could be both. And so how do we, there's just a diagrammatic picture of it. So for both of these, they have the same empirical formula, but we still don't know what the true molecular formula is. But the mass spectro can give us, help us with that one. So how do we go about doing it? Well, you'll weigh a substance. And so if you're given percentage values, the easiest thing to do is just to assume 100 grams. So you can start doing the problem. You start working with it. So you've got a certain amount of grams. So if it has like 90 and 10%, just turn it to 90 grams and 10 grams. And then we go and convert those elements into numbers of moles. So that we have X and Y and the numbers of moles here and here. So we're very close to an empirical formula. And then we need to get it to whole numbers. So we divide everything by the smallest one. Let's say that was N1. And then hopefully it works out to whole numbers. If it doesn't work out to whole numbers, we still need to times it. So if it's one of them's 0.5 times it by 2, one of them's 0.3 times it by 3, one of them's 0.25 times it by 4. If it's 0.2 times by 5, which is getting rare, these ones are very common. These are very rare. And if you happen to get in the gray area, I wouldn't think perhaps I would times that by 5. I would think maybe just round that off to 0 and say that's just due to experimental error. Okay, so let's just do a few of those and then we'll do molecular formula. So here we have probably a CH in analyzer, and it's come up with this substance and it's come up with these percentages. So the first thing we do is we assume it's 100 grams and convert all of those substances to number of moles. And then we write it out as a a formula, which will be in the empirical formula. And then we divide everything by the smallest number, which will be 3.2. Okay, so grabbing all those things and dividing by 3.2, we now get 151, which works out quite nicely as an empirical formula. Okay, now we don't know if that's the molecular formula unless we have a little bit more information, but we'll still work with empirical formula. So this machine's worked out that this compound's made up of this and this. So we convert that into masses and work out the number of moles. And then we get this, and here we have a situation where they're not whole we haven't got to the dividing by the smallest number yet. And here we have, that's not a whole number, so times them both by 2, and that's what we're saying the empirical formula is. Okay, so moving on to molecular formula now. So this is quite easy from the mass spectro to get. Now that we know the empirical, we can work out what the molecular formula is, because at least we have the molar mass now. So we'll just grab 1 divided by other and we'll get a factor. So I just basically do this. This is usually pretty obvious. It's usually 1's double or triple. You can just look at it and see it. but I'll use a formula for at least for the first one. Okay, so the whole divided by the part, and it'll come up with a number that's 1, 2, or 3 usually. So the empirical formula is the molecular formula, or it's double or triple that. So the molar mass is 194, and that's the empirical formula. So you need to work out what the molar mass of that is, and it's 2. So the empirical formula is double that, so you just times that by 2, and that's what the molecule is. Okay, just one more, and so we know the molar mass is this. The molar mass is this. What's the molecular formula? So we have this data here, so we'll do empirical, and then we'll see if it's the same as this or a factor of this to work out the molecular formula. So to convert all those to grams, work out the number of moles, get the empirical formula. That's not the lowest whole number ratio, so we have to get that to get an empirical formula, which is 48, which is ironic. That is the actual substance. So the molar mass is 98, which is double, so therefore it's times by 2. So that's the empirical formula, and that's the molecular formula. Okay, so have a go at a few of those.